Lesson 5-7, Example 1. Our objective is learning to multiply fractions. So here we have 1/4 multiplied by 2/5. And remember that we can think of that multiplication as of, so I could think of 1/4 of 2/5. So that's telling me, as I think about it, well, 1/4, a fraction of a fraction, I'm going to end up with something smaller than what I started with. So something's smaller than 2/5. Because I'm only taking a piece of this right here. So when I'm multiplying, just like when I was looking at whole numbers, and we could think of a whole number as the whole number over 1, and then we multiply our numerators and our denominators, we can do the same thing with any of those fractions. So here I can think of numerators 1 times 2, and then multiply my denominators 4 times 5, and 1 times 2 is 2, and 4 times 5 is 20. And if I reduce that down, divide both by 2, I end up with 1/10. So 1/4 of 2/5 is 1/10, and that is smaller than what we started with. It's smaller than our 2/5. So it's a reasonable answer. Let's take a look at this one then. 5/7 times 4/15, or 5/7 of 4/15. And I can think of this as 5 times 4, my numerators, over my denominator 7 times 15. Now, when I multiply this out, I'm going to come up with some large numbers. And so I can also use the greatest common factor to help me simplify this before I actually get to the final solution. So I'm going to think of this as 5 times 2 times 2. So I broke my 4 into factors, 2 times 2. And 7 times 3 and 5. So 15 became 3 times 5. Well, I notice that I have on the top something similar as the bottom. And 5 divided by 5 is 1. So I'm going to do that. I'm going to think this 5 is over this 5. So 5 divided by 5 is just 1. And I end up with just 2 times 2 on top is 4, and 7 times 3 is 21 on the bottom, and my solution is 4/21. So I'm already in the simplified form because I looked at those factors. Let's take a look at that again. 4/9 times 6/10. I can look at that and I can think that I have 4 times 6 on my numerators, and I have 9 times 10. And I'm going to think of those as factors for a moment. So 2 times 2, that's my 4, times 2 times 3, that's my 6. Over here, I'm going to think of this as my 10 first. So 2 times 5, that's my 10, times 9, 3 times 3. Well, here I have some factors that are in common. I have 2 over 2. That is 1. 2 divided by 2 is 1. 3 divided by 3 is also 1. So now I have 1 times 2 times 2 times 1, which is essentially 2 times 2, which is 4. 1 times 5, which is 5. 5 times 3, which is 15. And 15 times 1, which is 15. So 5 times 3, 15. 4/15. So I can use that greatest common factor. I can use those common factors there to reduce, to simplify before I come up with a solution. And I could actually start to see that sooner. If I was over here again, if I saw 4 times 6 and 9 times 10, I can say, well, I know they have common factors. 4 and 10 have a common factor of 2. 2 times, if I pull out a 2 there and a 2 there, I'm left with 2 and 5. 6 and 9 have a common factor of 3, and I'm left with 3 and 2. 2 times 2 is 4, and 3 times 5 is 15. Right now, if it's more helpful to look at it by pulling those factors apart, then I do that. Eventually, you'll start to be able to see it a little more efficiently.